Cool. Yeah, so hi, I'm Andy Nesling, and I'm going to be talking today about scaling our IoT solutions. So first of all, a little bit about me. I'm a tech team lead at Dyson in the connectivity team. I've been working in the sort of IoT space for about 14 years. I started off with automating electricity networks, so that's where I sort of got into this. After that point, I went into online electricity and gas monitoring for homes, and now I'm with Dyson helping us to connect our products. I'm absolutely passionate about Agile software development because I've seen firsthand the benefits you can get in working that way, and particularly delivering IoT solutions. So first of all, very briefly, a tiny bit about our products. So the first connected product that we launched was the Dyson 360i robot vacuum cleaner, which has got the most powerful suction of any vacuum. And it's also got advanced 360-degree vision system. It is amazing to see it going around your house cleaning. Now, when it came to actually connecting it, our aims were really to make connecting it actually enhance the features of the product. So not just a gimmick, it really, connecting it needed to give you something you didn't get just by having the product on its own. So one of the first things we were looking at was allowing users to quickly be able to set a schedule so that actually you can get the vacuum to go and clean your house when you're not there. So rapidly following on from that, though, is if you've got a robot vacuum that's sat in your hall and you've scheduled it to go and clean your house when you're not there, when you leave in the morning, it's sat there. When you come back in the evening, it's sat there. Did it do it? Yeah, you don't know. So one of the things that we put in is a map visualization tool, so you can actually see where it's been and what it's been doing. One of the other great features, and I absolutely love this feature, is actually getting notified from your vacuum that it's just gone around and cleaned your house. There's nothing better than being out at a coffee shop, getting a message through saying, yep, we've just cleaned your house. Brilliant, brilliant. So the next sort of range of products that we added was a range of connected air purifiers, which can remove allergens and pollutants down to 0.1 microns, pretty small. And it's particularly important where the indoor air quality can be up to 5 times worse than it is outside. And again, when it came to connecting that, we were really looking at how can we enhance the user experience by connecting it? What can we bring to the user they won't have just by having the air purifier on it in its own? So again, scheduling was one of those things, allowing you to set a schedule so that it will always come on and be purifying your home when you're there. But then very similar to the robot vacuum cleaner really was, well, I've got this purifier in my home, but how do I know? How do I know how well it's performing? So we put in some tools that will allow you to see, well, this is what the air quality is like outside, and this is actually what the air quality is like inside your house now. This is what it's doing for you. And the second that you can start controlling this purifier remotely, you can do things like, I'm at work, I can see before I go home, oh, my house is looking pretty bad. Let's start it so that by the time I get home, actually it's all clean and nice and waiting for me. And then one of the other things is then looking at how have things changed over time? What does it look like when I put it on? What effect does it have? And so starting to put in some trending so that people can actually see, well, this is the effect, this is the benefit I'm really getting from having it. So where are we now? I mean, currently we've got hundreds of thousands of connected users spread across 30 countries, and the rate at which we're getting new connected users is increasing all the time. What's next for us? I mean, we've got an increasing range of products, and we've got an ambition to connect more of those, really, so that we can start extending the experience that people are getting from those products already, with some of the tools like a richer user interface. So, I mean, we are going on really a journey in transitioning from being a product company, a company that makes and ships physical products, to actually providing solutions to people, and that's certainly quite a change, and we're going through that process at the moment. So, what we're looking to do is marry Waterfall delivery for shipping physical products with Agile delivery for delivering software, and it's not the easiest thing to marry up. It really isn't. So some of the things that we're using to allow us to do that are focusing very clearly on what are the requirements that we must have when we launch the product. So what is absolutely essential to be there at launch, and then what can we add later? So in some ways, you're working a little bit waterfall to get to that launch point, but once you're there, you can then really start iterating and learning from actually having the products out there. One of the other things you're also thinking about is, well, where do I put the user interface? If the entire user interface is on the product, it's very hard to change that after I've shipped it. Whereas actually, if I've got the user interface in an app, it's much, much easier to change that after it's been shipped. One of the other techniques that we're using is user story mapping. There's some great videos online and a book written by Jeff Patton on that, which really are looking at what's the user journey from physically getting the product through and taking it through to unboxing it and connecting it and using it, and looking at, well, okay, what do we need at each of those different levels? And what do we need at launch? What can come later? And one which I will get onto again and again as I talk today is always have the ability to firmware update. You may well think, oh, I don't think we'll need to. And certainly if you're coming from a product company, that's quite an alien thing, really. I mean, once I've shipped it, it's there. I can't change it. But actually, once you start having the ability to change the user interface after you've shipped the product, it's very important to also be able to update the product to allow you to really get the most benefit from that. So, I mean, one of the other challenges that we've had is Dyson is already established in an awful lot of regions around the world. And so there's an expectation that when we launch a new product, we're launching it in more than just one region at the same time. So we can't get very, very good in the UK and then start moving out. So we are launching it in multiple regions at the same time. And some of the things that's forced us to consider very early is, well, where there are regional regulations that mean that data has to stay within that country, we're having to look at, okay, well, given that we're going to actually have to have a service now located in that country, what are the tools that are available to us in that country? So the cloud tools that may be available in the UK and the US, not all of those are available in all the regions that you're looking to deploy into, and so you're having to think about, okay, well, how do we do that? And also speed as well. So particularly where there are firewall limitations, for example, on a country, and bandwidth limitations, you've really got to think quite seriously about, okay, well, where are we putting the service which is actually collecting this data and allowing users to interact with it? And another one is user experience. So something that's important to a user in the UK could be quite different to something that's important to a user in Japan, for example. And so where we're looking to present that information, we've got to be very conscious of that. It's not just a matter of, well, it's the UX that's going to work in the UK is going to work in Japan. We just have to change the text. You're having to start to think about much more than that. And one of the things that's really helping us with that is leveraging local experience. So actually using engineers from the different regions to feedback, okay, what's important in terms of actually getting this product shipped in this country. What is it that's really important to people? So having those people on the ground that can be feeding that back to us has been absolutely essential. So one of the other things that we're then thinking about is, okay, well, we talked about where should user interface sit, but also where should the logic sit? So one of the options, I mean, one of the first things we're thinking about is, well, what features have to be connected, and also what features have to work when there is no connection? And a great example of that is the guys who are working on connected thermostats. And when your network connection is down, you still want your heating to come on in the winter, regardless. So if the internet's down, you still want to be warm. So you're starting to think about things like that. I mean, so you can put the logic locally, you can embed the logic in the firmware in the device, or you can set that up in your back-end systems. But wherever you put it, you always want the ability to update it. So that, because over time, you may well want to change where that logic sits. So you need the ability to be able to move that around. So if you're actually embedding the logic in the device itself, you get some real advantages. One of them is that it's robust and fault tolerant. You're not dependent on a networking connection or a reliable Wi-Fi in order for the system to behave how the user's expecting. Also, it can be very fast. I mean, that's less of a problem now. Now bandwidth to homes is improving. One of the downsides, though, of putting logic actually in a device is it is harder to change. Even though you've got the ability to update firmware, it still is harder to change, particularly when that rollout will happen over time. And because of that, you have to consider backwards compatibility, where you've embedded a lot of logic actually in the device. You're going to have devices which are running different firmwares at different times, and the way that you're presenting information out to people, you've got to be considering that. So if you decide not to embed all the logic in the device and actually put it in some of your back-end systems, one of the downsides is it can be slower, and it is harder to make fault tolerant. So if you've got a bad Wi-Fi connection in the home, you can't guarantee that the messages are going to get there. So you've got to be thinking about, okay, it is going to fail, so how do we retry? And if we are retrying, how long should we retry things for before the user experience actually gets even worse? But the advantages are, it is easier to change. With the release of your back-end systems, you can change the behavior of all of your products out there without having to do it in bits. And the other thing to think about is, well, what's actually going to scale? So if I'm putting a lot of logic in the cloud, so I'm doing a lot of intensive processing in the cloud, once I start having hundreds of thousands or millions of devices that have that requirement for processing, what's that going to mean? How costly is that? Whereas if I actually embed that logic in the device, it may in fact be much more cost effective. So and this is one of the examples of where we've had to think about this in terms of, in all our connected products at the moment, we've had to think about scheduling and where should we schedule. So if we schedule actually in the device itself, if it's not got a network connection for whatever reason, it's still going to go on and do what's expected. But the downside of that is it's harder to test. If you're looking at testing the behaviors of different time zones, daylight saving changes, all that sort of stuff, it's that bit harder to test than actually if that logic was in the cloud. But regardless of where you decide to put the logic, and we're trying both ways to see what works best, and for different applications it's better to have the logic in one than the other. But whatever you do, we found it very important to always use UTC. So in the device it's UTC, in the cloud it's UTC, in the app it's UTC, everything UTC, so that you don't go bad. So then, moving on, and in some ways related to where do you put the logic, is the challenges of real time. So the sorts of things that we're thinking about here is, well, what actually has to be real time? And certainly, I mean, control is one of those things where it's very important that when I'm controlling something, I need that very fast feedback that it's doing what's expected. And also looking at, well, what can I queue? What doesn't have to be real time? So, for example, if there's a notification coming from the device to say that I've finished cleaning the home, that's not necessarily something that has to come out the second that it's finished cleaning. And so balancing those two things up, you can start to spread the load on your system, really. And also, the other very important thing to consider is consistency. If actually what somebody is seeing on an application is different than what they're seeing on the physical product, very quickly people lose confidence in the product. So you always have to think about whatever I show here, it's very important that's reflected in what the actual product's showing as well. And one of the other things is thinking about, well, what information do I have to save? The second I start persisting information, again, it can be harder to make that fast. And so what information do I need to persist? What information can I live with literally just being there to allow somebody to do something quickly? So the next thing, and one of the hard things really with IoT devices is the load that you get from them. So the good thing about the load from IoT devices is it is predictable. Given a particular bit of firmware, the load you're going to get from them is going to be the same for every single one of them. They're going to be doing the same thing again and again and again. The other advantage you've got is that you can only make the things so fast. And actually, you know in advance how many you're going to make and when they're actually going to be out in production. So those things are working for you. The things that are working against you is that unless you do something, it's quite likely that the information coming from these devices is going to be coming to you at the same time. So you've not got this nice steady load. You've, for example, got every hour, everything tells you something all at the same time, which is hard. And the other thing which is particularly hard is these things don't give up. If you've got a website and it's running slow, people try it and then they go away. I'll come back to that later. IoT devices, they never give up. They don't care if you're struggling. They keep on hitting you. So what can we do about that? Because the teeth can be pretty sharp. They really can. One of the first things to do is consider the data rate. Consider what do you actually have to send from the device. Although there's ability to send an awful lot of information, how much of that do you actually need in order to provide the user experience that you're looking for? And actually, how much of that has to be reliable as well? How much of it can be fire and forget? One of the other things you can then start looking at is, well, actually, I don't want everything hitting me the same time every single hour. I want to randomize that. I want to spread that out. And I want to do that in a way that is not affecting the user experience. The other thing also is, well, actually, if the system is slow because there is an awful lot of load on it, you want all the devices to back off and to randomly back off as well, so that it gives your system a chance to recover. One of the other things, and particularly important, for example, when you're starting up your system, bringing your gateway up, is actually looking to queue the responses. So what can I actually queue to allow us to get over that hump of everything connecting all at the same time? The next thing then is looking at blacklisting. So actually, if one of your products starts behaving, it gets a problem, it starts behaving in a peculiar way, you need the ability to stop talking to that device. But when you do it, the way that you stop talking to it, you need to be doing as early on as possible. If it takes quite a bit of resources to look at the device and say, oh no, I shouldn't be talking to you, go away, actually just that behavior can put an awful lot of load on your device, on your system. So you're looking to make that decision as early on as possible, so that if there is a problem, you're not having to spend a lot of time servicing that. So the other things that can then work for you are really automation, and this is what we're really pushing on at the moment. So when it comes to load testing with IoT devices, I mean, the fact that it's now possible to spin up a number of VMs in the cloud and run, or even on one instance, thousands and thousands of emulators of your particular product, run your test and then shut it down again so that you've not got that ongoing cost is absolutely brilliant. The things that we're finding, though, and the things you need to consider are, when you're looking at that load testing, the sort of metrics that you're looking at when you're load testing want to be the same metrics that you're using to monitor your system in production. And that's very important. So as the load that you're seeing in production gets to the load that you've been simulating in advance, you're using that to say, well, actually, was our simulation accurate? Were we actually simulating the load that we are now seeing? And if not, we can now use that information to start changing our simulation to ensure it's representative. I mean, it can be very easy to basically hit the system much harder than actually it will have in real life, which means that basically your system is just costing you more money than it needs to at that point in time. One of the other things is where you are simulating load from lots of devices, or on a particular VM, for example, it's very important to actually monitor the client. So where you've got thousands and thousands of instances, this is the emulator on this device running, you want to make sure you haven't maxed out the machine it's running on, because you may think that actually you're putting a lot more load on your system than you actually are. So it's very important to know that actually, yeah, the client is not maxed out, and it is actually putting that much load onto the system. The next thing as well is you're not just looking to test the steady state. So you're looking to, well, what happens if all the devices connect? If there's a network glitch and all of a sudden all the devices go away and then come back all at the same time, how do we cope with that? So what sort of things are we looking to automate? So we are looking at automating acceptance testing of the subsystem. So we're looking to automate the testing of the mobile application in its own right, mocking out the cloud and mocking out the devices so that we can test that the app is going to work correctly, and doing the same thing for the cloud, doing the same thing for the devices. We know that those parts of the system are doing exactly what's expected of them. One of the other very important things then is actually testing the contract between the devices. So ensuring that the contract that, for example, the robot is relying on to talk to the cloud, that contract is not changing, either when the version of the cloud changes or you're changing the firmware. You want to know that that contract is still valid. So we're testing the subsystems, we're testing the interface between those systems, but also then we're looking to smoke test, well, what happens when we plumb it all together? When it's actually all connected together, does it work? And also, for that smoke testing, if you can run those smoke tests in production, even better. Now, it can be hard. I mean, there's some smoke testing that is hard to run in production. For example, registration. You may not want to be creating lots of effectively gash accounts on production from just testing that registration works. But other things, for example, I've got an account that a pre-assigned account on production that I'm going to use to make sure I can always control my device. That stuff can be easier. But regardless of what we're doing, we're always looking to automate as much of that testing as we absolutely can, and also automate the deployment of that testing, so that we're bringing up a new environment to test against. That is automated, so it's very easy for us to spin that another environment up to run those tests against. So in terms of looking at what we're monitoring, and what should you monitor? Well, basically, monitor as much as you possibly can, but also monitor KPIs, not just looking at memory usage or CPU usage. Monitor, well, how long is this particular user journey taking, and things like that, and get those stats into the same tool that you've got, for example, for CPU and memory usage, and because once they're in the same tool, it's much easier to start to see, oh, okay, these two things are related. It may not tell you cause and effect, but at least you know that they're related. One of the other things, which is not, I guess, immediately obvious, is that monitoring IoT devices is just like having a whole heap of servers out there. So actually, you can monitor your devices as though they are just an awful lot of servers. And again, looking at KPIs, looking at what firmware versions they're running, all of that stuff, getting that all into the same tool is tremendously helpful. And really part of that is look at trending, not just alerting. So alerting is excellent to let you know that there's a problem now. But actually, if you're starting to trend a lot of this stuff, you can actually tell before there's a problem that there's going to be a problem and do something about it before it happens. So one of the hard things in IoT is remaining backwards compatible. So one of the things that you have to consider is, so you've done the work where actually you are going to be able to firmware update your product after you've shipped it, which is brilliant. But one of the things you have to consider is, but this product could be made, it could be sat in a warehouse for some time before it gets installed, and equally, once somebody's taken it home and got it up and running, they may not connect it to you straight away. So actually, the firmware that you shipped with a unit is likely to be in that for some time. And in order for you to be able to update it, you still need to be able to talk to it. So it's very important to ensure that actually, for the firmware that you've shipped out in units, you can always talk to those so that you can actually get to the point where you can update them. One of the other things that you then start to think about is, well, actually, I don't want firmware updating to be the first experience somebody gets of the product. As soon as they install it, and they're really excited about getting their robot vacuum cleaner cleaning their home, I'm sorry, no, we can't for a while because we're updating it. You're going to have to wait. So we're looking at, okay, well, what sort of, for example, degraded features could the user have to get up and running with it and then update it later so that they can then get all of the features. But that out of the box, they're able to get up and running with it quickly and start enjoying it. So at the same time that you've got various different versions of firmware out in the field, you've also got different versions of your iOS and Android apps out in the field. And also, as you're deploying your microservices and you're deploying them in such a way that you're going for zero downtime, so you've got multiple versions of the thing running at the same time, you start to get an awful lot of different variables here. There's an awful lot of things that all have to start working together. And this is really where, again, testing the contracts that each of these things is relying on is essential, so again, so that you don't go mad, so that you know that whilst there are different versions of this out here, I know that the key parts of this system are going to be working together. So you've got all of these variables. The one thing you want to try and avoid as much as possible is having a whole nother set of variables by doing different things for different regions as well. So if at all possible, try to avoid doing specific things for a specific region. And the other thing, really it comes from allowing these things to happen, allowing you to have different versions of the app out there and different versions of the firmware, is you always need to be thinking about, we cannot tie releases together. We cannot say that we're going to push out this firmware release at the same time that we're making this server change, because there are always going to be different versions of those things out there that you can't control. So security in an IoT world is a difficult one, and we've had some great talks on security today. We really have. I'm really not going to go into this much at all. We've got one of our security experts from Dyson with us today, so if you want to talk more about security, I can point you in his direction. So what approach do we take? I mean, the first thing is, basically, we try not to do anything special. We look to take a well-trodden path. If we're doing something special with related to security, then chances are we're doing it wrong. Also, we're very keen to embed security into the development process, so it's not something that happens right at the end. It's not a penetration test that we run right at the end. We want basically security input as we're actually developing. And very importantly, we're not just looking to test the servers, we're also looking to test the devices, so that we don't get our devices taken over and all of a sudden we've got somebody using our devices to run a denial of service attack on somebody else, or even worse, on ourselves. And as much as possible, and something that we're looking to improve on, is actually automating that testing. So getting that analysis done as early as possible. So once you've got all of these devices out in the field sending you data, you can start to do some really cool stuff with it. So first of all, how do you get at the data? I mean, very quickly, I mean, you'll start to have billions and billions of anonymized data points that has got a wealth of information in there. But one of the first things that you want to do in order to start actually looking through that is get that data off the production system. Get it into a data warehouse somewhere that's specifically designed to allow you to run the sort of queries you want to be running against it and not affect the performance of your production system. And also, once you are looking for, you need to have, once you've got specific questions to ask, what's the behavior of this under these conditions, then you can start leveraging things like machine learning to answer those specific questions. So how are we using the data? So we're using the data to better understand how our customers are using their products, which is absolutely wonderful for us, because it means that our innovation now doesn't stop when we ship the products. So in some ways, it actually starts. So the first bit is getting a product out there, which is excellent and a great user experience to start with, but we can now make it even better, because as it's now running, we're collecting more data, more anonymized data about the way it's performing, which allows us to actually improve the user experience after we've shipped it, which is enabling us to do even more powerful data-driven design. But in order to leverage this, in order to make the most of it, you need the ability to be able to update the devices. So if you learn a lot of information about it, and wouldn't it be great if we could just do this, but you've not got the ability to update the device, you're limited by how you can, what you can do with the learnings from that. So to wrap up, what are we learning? One of the things that we're always learning is ensure that connectivity is extending the product. So it's not a gimmick. So having connectivity is actually giving the user something they wouldn't have if they hadn't connected it. And also, very importantly, and particularly important for a product company moving into delivering solutions, is considering what is actually required at launch. What is the MVP? What we must have at launch to really excite the users? And then what can come later? What can we iterate as we've got the product out there and we're getting more information about how people are using it? Then also consider where the logic's going. So is the right place to embed that logic in the device, or should that be in a back-end system? And equally, well, changing that over time. as we learn more about it. One of the things that's essential in order to allow us to do what we're doing is looking to automate as much of that testing as possible, because that's allowing us to release more frequently. And also using that data to continuously improve our products. So finally, just to say, we're hiring. We're expanding tremendously at the moment what we're doing with connected products. So we're looking for cloud developers, app developers, UI, UX, testers, security. We're recruiting both in Malmesbury and here in Bristol. So if you're keen to work in a very, very innovative company that's doing really quite cool things and want to have your lunch underneath a lightning jet, do come and have a chat with us. We've got a stand outside, and please grab me afterwards. Thank you very much.
Anybody have any questions?
We've worked with some other big name suppliers of embedded stuff. Something we do with them quite a lot is embedded health monitoring. So have you looked at health monitoring of your product? So for example, your product will know when it's about to wear out, so that a technician appears on my doorstep and fixes it before it fails.
Absolutely, that's something that we are looking into at the moment. Yes, because there's an awful lot of value you can get from that you wouldn't have without it being connected.
Yeah, it's very cool.
Yeah.
You mentioned machine learning on the server side.
Yep.
Are you looking into machine learning on the machine side, on the IoT side, in the actual product?
I'm limited in what I can say, but let's just say we're looking to leverage machine learning in a number of places to really allow us to enhance our products.
I'm just really interested how you've dealt with the sort of moral aspects of potentially monetizing the product data, and how you've gone about that as a company, how you've kind of thought about the data that you're collecting, quite intimate information about people's households, and whether you've done that, how you've gone about doing that moral learning.
Yeah, so we've got a lot of people who are considering that an awful lot. So in terms of the data that we're looking to analyze, it's very important to us that that data is anonymized, so there is no way to tie that back to anybody. But also, I mean, we're also very conscious about what we're using that data for. So we're using that data to allow us to improve the products for our users. So that is always key in our minds, is we're using the data to make the products better for our customers, and that's the primary purpose of looking at that and analyzing that data. And we're keeping that absolutely internally, absolutely. Yep. Yep.
Hi, do you have much experience with using WebSockets with your IoT devices, and if so, has it been effective?
I can probably, after this, point you at some people who can talk to you about a lot more depth than I can.
Hey, so it sounds like you've kind of assumed like you control the entire ecosystem, and I was wondering if you like have any thoughts or opinions on like kind of open standards. So like in like the ideal smart home, you don't want to be like locked into one manufacturer, one vendor. You want all your smart devices to kind of interact together.
Absolutely, and that's something that we're very conscious of. So we're looking to use technologies and protocols that a number of other people are using, because we get a lot of benefits from using those standard protocols also. And actually interoperability with different systems is going to be really, really very important to us.
Good, thank you.
Cheers.